Okay. Thank you for coming, guys. So today we have Dr. Robert Richardson. He's an applied economist and a professor in the Department of Community Sustainability at Michigan State University. And without more introductions, I'm going to let him go ahead and start.
Thank you. Thank you very much for the invitation to visit the department. I thank Margarita Valendia, Delton Gerloff, and others who extended the invitation to me. It's a pleasure to be here. I have a family in Knoxville, so I love to come to this area as often as I can. I am going to be presenting, as you saw the title, on some research fairly recent in West Africa relating to trade-offs between agricultural ecosystem services and adaptation to climate change. The method wasn't described in the title, but I am using choice experiments, which from walking down the hall is a familiar method for some of you. I'd like to just briefly introduce myself. I'd like to talk about my work in studying trade-offs in decision-making. And then I'd like to go into the research context here, give a little bit of background in Mali, describe the choice experiments that we did there, which were related to hybrid sorghum and perennial sorghum. And I'll get into the distinction of those in just a minute. And then I'd like to briefly discuss some conclusions from that work. I would like to acknowledge Kurt Waldman, who was a postdoc who worked with me on this project. And the project was funded by the Bill and Melinda Gates Foundation. So in terms of who I am, I earned a PhD in agricultural and resource economics from Colorado State University, and I pursued that because I was really interested in environmental economics. I used some behavioral economics approaches in my dissertation, and that eventually led me to my interest that's for 15 years or so in ecological economics, where I do a lot of work on the values of ecosystem services, measures of socioeconomic well-being, sustainability, and so forth. Almost all my work has been interdisciplinary. I collaborate a lot with agronomists, with soil scientists, with forests, biologists, wildlife ecologists, and I really like being at the nexus of different ways of knowing and thinking. And I'm active in both research and teaching at Michigan State. I've been there since 2007. As Margarita said, I'm a professor in the Department of Community Sustainability. We're a kind of interdisciplinary department in the College of Agriculture and Natural Resources. I'm also associate chairperson of my department now. I'm president of the U.S. Society for Ecological Economics, and I'm a former member of the Board of Scientific Counselors of the EPA. So it maybe seems strange to begin with methods, but a lot of my work, as I said, is at this focus on trade-offs in decision-making. And we draw from behavioral economics in order to examine how people confront those trade-offs. We draw upon this using choice experiments, which is rooted in Lancaster's characteristic theory of value, famous paper from 1966, where he basically suggested that rank ordering of goods according to their characteristics or attributes that are embodied in the goods can be used to study the value of those attributes, simulating real-world decision scenarios. Obviously, we do this in a way that measures stated preferences rather than revealed preferences. On the one hand, this is valuable because we can use hypothetical scenarios like hypothetical markets, one of which I'll talk about today. It's another alternative to the contingent valuation method for placing economic values on non-market benefits. But because it's stated preferences and not revealed preferences, it is subject to the potential for hypothetical bias. It's a broadly applicable method, and I have all of these citations here merely to demonstrate how this method can be applied in different contexts. We used it to study crop attributes, which is what I'll talk about today. I've used it before in studying preferences for environmental management. One of my PhD students now is using this technique to study preferences for dairy products, actually in Mali. I've used it before to study outdoor recreation in the context of climate change. So really broadly applicable. As for background in Mali, this is a landlocked country in West Africa. This research was really motivated by two sort of dual forces. One is population growth, which of course implies increasing demand for food, which is a challenge in this very arid environment. The second dual force at play here is climate change. It's driving a lot of changes in decision making about agricultural cropping systems. This is manifested in warming temperatures, highly variable rainfall, and increasingly frequent occurrence of drought. Sorghum as a grain crop, there's increasing interest in sorghum. Rice and millet are the dominant cereal crops in Mali, but a growing interest in sorghum in part to some of its characteristics. It has the capacity to adapt to changing conditions. It's a pretty hardy grain crop, and it's fairly resistant to drought, to soil salinity, and to higher temperatures. So it can grow in a fairly marginal environment. Yet agricultural policies in Mali don't tend to target sorghum, so it's sort of overlooked in some research. An image of a healthy sorghum field. There are a variety of sorghum varieties, diverse varieties in this crop. Some that takes advantage of certain spatial niches in the country because ecological zones vary from very wet to very dry in this country. It allows for the diversification of crops, spreading risk, overall improving the resilience of the farming system. We're focusing today on hybrid and perennial varieties, which can be seen as sort of different technologies for adaptation to climate change because of their characteristics, which I'll talk about in just a moment. The first is hybrid. This is a form of sorghum that is bred by crossing traits from diverse germplasm, by combining certain traits that are desirable, such as disease resistant, with traditional varieties to get the kind of crop that's desirable for the farmer. It creates more productive varieties, and more recently, hybrid sorghum has been bred for short duration. This is its advantage for climate change. If you have a very short rainy season, a short duration sorghum crop can help reduce vulnerability to climate change. It reduces the time that the crop is in the field. On the other hand, perennial sorghum, as you might suggest by the name, as a perennial plant, would not need to be replanted every season. It does have the downside of yield losses in the near term, but hardier ecosystem services, agricultural ecosystem services in the long term. So it's really an investment in the long-term resilience of cropping systems. And in this environment, it's often very challenging for farmers to think long-term when needs have to be met in the short term. It does have the potential, as I said, to improve agricultural ecosystem services, but we don't know a lot from research about preferences for crop duration. And having these crops in the field, certainly we don't know much about the gender implications of men and women who grow this crop. Perennial grains, just to go a little bit deeper, this is what the Gates Foundation was interested in. The project was called Perennial Grains for Africa. And we did this kind of work in several countries. They were interested in it for the potential to increase food security. And one of the reasons they're interested in it is some of the characteristics. Perennial grains of all types have very long root systems that allow for greater water uptake and nutrient uptake. You don't till the soil as much, there's less soil disturbances. And then they support numerous ecosystem services, including things like soil retention, not surprisingly, erosion control, nutrient cycling. Those longer roots also sequester carbon, among other things. So our objectives for this project were to examine farmers' preferences for different cropping systems with the focus or emphasis on climate adaptation. We employed discrete choice experiments to examine farmers' preferences for the attributes of perennial and hybrid sorghum, the attributes of both of those crops. And then we were interested in considering the heterogeneity of preferences. Do most farmers want the same kind of attributes, or is there a widespread heterogeneity, and particularly with regard to gender? The theoretical model suggests that this indirect utility V star is not observable, but we can observe direct utility through the choice that farmers make, and they'll make that choice if it maximizes their utility. They'll opt out of that choice if it does not. So a farmer that faces K alternatives will choose the option J if the option J generates greater utility than all other K options, if you will. Skip one there. So therefore, the choice that maximizes utility is a function of a vector of characteristics of all of the attributes of that choice times the parameter, which is a vector of preference parameters, beta, that vector of weights mapping attribute levels into utility. And then, of course, the error term is a stochastic component of utility. So again, we explored trade-offs between hybrid and perennial sorghum crops. In some regions of Mali, cash is not widely used. People trade. So we used sorghum as a currency. So the price variable here is actually sorghum yield, and you'll see that in the, we wanted to get around a cashless society by using something that's commonly used, which would be grain. We wanted to capture the major differences between the cultivation of these two types of sorghum. To get to the sort of gist of it, perennial sorghum is associated with higher soil fertility, and it tends to produce more biomass for forage and livestock. Hybrid sorghum, as I mentioned before, tends to be bred for shorter duration, but often has the inability to reuse the seeds. So those are some of the characteristics that we wanted to explore with farmers to determine how important are these in your decision to either adopt this crop or not. And then we can, once we have estimated the parameters, we can convert them into marginal rates of substitution, or something like willingness to pay by dividing the beta for any particular attribute by the price. That gives us an estimate of willingness to pay for that attribute, how much a farmer would value a particular attribute. Okay, I'd like to briefly discuss the attributes that were included in the two experiments. Because these are two types of crops, the attributes are different in each experiment. So in the hybrid experiment, we used 5 attributes, and you can see the levels of each one. Seed requirements, so the amount of seed required compared to traditional sorghum varieties. The plant duration, so it could either be early maturing, medium, or late. The ability to reuse the seeds is yes or no. The cost of the seeds varied, and then the yield would be relative to the previous year in percentage terms of that farmer's own yield on a given acre. And obviously, these are all varied as we repeat the experiment over and over with.
Robert, can I ask you a question?
Yes, absolutely.
So those sorghum yield scenarios, are those based on field trials you conducted in that particular area, or those are just simulations based on information you have from other field trials?
Actually neither. It's just basically asking the farmer, hypothetically, if you had some of these attributes and you know that your yield would be 120% of whatever it was last year. So it's relating yield to that farmer's own experience. Yeah. So it really has nothing to do with the ecological zone or what the potential in a particular area. It's relative to the farmer's own perception of how yield is important relative to, say, the cost of seed. The second experiment is the perennial sorghum choice experiment. It has slightly different attributes because of the nature of the crop. The seed requirements in this case are negative because they require less seed. You don't replant them every year. The labor requirements tends to be a labor-saving technology because you don't till, it grows back, you don't plant every year. We gave low and high forage quantity, so the amount of biomass, leaves, and other residue that could be used for forage. And then soil improvement was either low or high. And again, this is relative to the farmer's own perception of what soil yield is. So I have a farm, and the scenario would either be lower soil quality than I have now, or a better soil quality than I have now. And then finally, sorghum yield. In this case, they are negative relative to your own experience, because I mentioned before, perennial grains tend to have yield sacrifices.
I have another question.
Yes.
farmers tend to connect soil quality with nutrients, like nitrogen, phosphorus. How is that different when they connect soil quality with yield? When you have that soil improvement, how do you know that's different from the perceptions of soil of yield improvement?
Well, it's interesting because we've done, like I mentioned, we did the same kind of experiment in 3 other countries. And what we basically found out in every one, and you'll see it here too, is that farmers are willing to sacrifice a bit of yield for a gain in soil improvement. So they recognize that they have degraded soils, and they would give up a little bit of yield in order to get better soils. And that'll come out in these results as well. This is a map of the country. The gradient that you see goes from very low rainfall in the north to high rainfall. I consider it high, 1,300 millimeters. Certainly a lot drier than Tennessee. Mali has 8 regions, and in those regions there are 49 cercles, which is a kind of second administrative, you might think of it like a county, second from states. We chose 3 cercles from low, medium, and high rainfall zones, and you can see them here, Tomini and Douala and Bogini. So from those 3 cercles, we selected randomly 6 villages in each unit. Then we asked permission from village elders to interview 20 people in each village, and we aimed in every one of them to identify 10 women and 10 men. We employed 2 choice experiments, again, hybrid and perennial, with all respondents, and we collected 318 complete observations. Just to give you a sense of the context here, the average size of land area cultivated, was just under 2 hectares. So this is equivalent to under, say, 5 acres. Also, to give you a sense of farmers who market their grains, the average distance to the market is quite some distance, almost 19 kilometers. And then distance to a main road is around 42 kilometers. So some of these regions are quite remote, adding to the challenge of selling grain. We did design an orthogonal experiment, which is basically combining as many possible combinations of attributes as possible. We divided them into 6 blocks, and there were 4 choice sets in each block, which allow us to repeat choice sets with farmers. There was an option to opt out. So every farmer was presented with 2 scenarios, A and B, and then option C was a rejection of both scenarios. So they can opt out and choose neither of the scenarios under both experiments. We had illustrated booklets of these choice sets, and I'm going to show you an example, but they were booklets for each of the 6 blocks. This is an example of one of the choice sets. We used images to make sure that it was easily understood but across people of varying literacy levels and rates. So when there were greater or lesser seed requirements, the size of the seed block increased, labor showed more people working, and so you can sort of see on down how these choice sets looked. So you have option A, option B, and then you can opt out. And we want farmers to focus on the characteristics of the scenario. This is just a sample. Again, there were many of these choice sets. Okay, upon collecting the data, we used a random parameter logistic model, RPL, or sometimes called mixed logit, to run the regression. Mixed logit, or random parameters logit model, allows us to control for standard deviation in choice attributes. It also allows us to meet one of our objectives, which I mentioned before, was to explore heterogeneity of preferences among individuals. And then we also use the RPL model with interaction effects to study the gender question, where we interacted gender with each of the choice attributes. And you'll see how that looks here. So this is the results of the hybrid choice experiment. And you see 3 sets of results. One is the random parameter logit model only. The second is the RPL model with the gender interactions. So you see female times seed requirement, female times plant duration to get the gender interactions. And then the kind of summary result can be seen when we model in willingness to pay space. So you can imagine these being direct. So you see that there is no willingness to pay for the sorghum yield because that is our price. So all of these divided by price would allow you to estimate willingness to pay. Now, how would you interpret this? Farmers have a negative value for plant duration. They don't want the plant in the field for a long time. Obviously, it's vulnerable then to when the rains stop. But what they care far more about, more than 6 times the amount, is the ability to reuse seed. That is a very valuable attribute. And when hybrid seeds cannot be reused, farmers reject them. The opt-out dummy is positive and significant, indicating that at the end of the day, farmers do prefer hybrid over traditional sorghum. And then also in the hybrid model, we did estimate random parameter standard deviations. This is the part of the model that allows us to test for heterogeneity of preferences. So what you can see is that something like plant duration is not significant, meaning there is homogeneous preferences for short duration crops. There's not a lot of variability in terms of preferences for long duration. There was heterogeneity of preferences in the ability to reuse seed, and it was largely on gender lines. This was more important to men farmers than to women. There was also heterogeneity of preferences in the cost of seed. That was significant. Okay, turning to the perennial model, a few things that jump out here when we go to willingness to pay space is that farmers do value, they have a positive value for biomass that is generated for forage that they can use for forage, and that is an important attribute of perennial crops because they're growing and dropping leaves all the time. But again, far more valuable to farmers is soil improvement. So this is where we get to the point I was responding to your question, that farmers would sacrifice yield in order to get soil improvement. If you monetize this, it turns out to be a very small amount, around 5 cents when you convert from CFA to dollars, but not a terribly small amount for these farmers. The opt-out dummy in this case is negative and significant, meaning that at the end of the day, farmers would prefer traditional varieties of sorghum over the perennial. So there are attributes of perennial sorghum that farmers like. They just don't like the crop. And partly it's the idea that it would be in the field for a very long time, subject to predation by goats, and all kinds of other reasons that they reject the perennial nature of the crop. Finally, on the standard deviations, we can look at heterogeneity of preferences, and we see that there is great preference heterogeneity for all of the attributes. It's partly because perennial sorghum is hypothetical. It's hypothetical as a crop. ICRISAT has been breeding perennial sorghum for some time, but there's not widespread adoption of perennial sorghum because it's not fully developed as a technology. So the results suggest to us that perennial and hybrid sorghum are fundamentally different technological options for farmers. Even though it's the same crop, it's sorghum, the attributes of these two crops are fundamentally different, and farmers look at them and their attributes as being very different options. On the perennial side, again, the most important attribute of perennial sorghum is soil improvement. Farmers recognize that they're farming on degraded soils, and the potential to improve that is valuable. The downside is that soil improvement happens over a very long time horizon. So this is valuable to farmers if they could attain soil improvement in the near term. The nature of perennial grains is that that benefit doesn't come, it's not realized until the very long term. But it was valued as 3 or 4 more times than even biomass production. On the hybrid sorghum side, as I mentioned before, the most important attribute of hybrid sorghum is whether or not the seeds can be reused. Farmers would have traditionally hand-selected varieties that had desirable attributes and replanted them in subsequent seasons. If you can't replant the hybrid sorghum seed, it's very unappealing to farmers. So to conclude, and we'll have plenty of time for questions, perennial crops have little appeal to farmers unless they can provide some substantial ecological benefits in the near term. I didn't show results from other countries and other types of crops. We did this with perennial pigeon pea in Malawi and southern Africa, and had the exact same response from farmers, that the long-term benefits are really not worth the short-term costs of obtaining those. Increased forage and forage biomass and improved soil fertility are valuable, but only at a relatively small yield reduction. The acceptability of hybrid crops is largely hampered by the inability to reuse the seeds, and we saw widespread, significant, and homogeneous preference for shorter duration. That was an interesting finding. That preference for shorter duration crops was far outweighed by an aversion to seeds that cannot be used. So we believe these findings have important implications for policy, for agricultural policy, both for the long-term provision of ecosystem services and the near-term adaptation to climate change in a very arid environment. I thought to end with a point here that I think many of you are already aware of, because I see the method has been used a lot here to study grass-fed beef and other consumer products. But I thought, although this research takes place in Mali, it's certainly broadly applicable to agricultural and natural resources issues in the United States. You can imagine farmer preferences for improved cropping systems using this kind of method, valuing air and water quality at the household level, household preferences for transition to renewable energy. That's something I'm working on right now. I'm also working on some work related to consumer preferences for food characteristics. And I mentioned before some previous work that we had done on valuing outdoor recreation under climate scenarios. Are people likely to use national parks or waterways differently if the characteristics of the climate change? So broadly applicable methods, but those are the findings from our experiments in Malawi. Again, I'd like to thank the department for the invitation to be here, and I'm happy to entertain some questions. Yes?
So I'm curious about, again, your soil quality measure, like the perceptions of soil quality. And maybe it will help me better to understand the landscape in Mali. So for example, here in Tennessee, I'm thinking when you go to Ranger County, which is that county that produces a lot of tomatoes, the landscape, because they're very hilly soils, farmers can observe elements of erosion, loss of nutrients, and they are more aware about kind of like the long-term impact just because of the landscape. There is also an educational component that makes them more aware, just because you are saying, I mean, they will not observe improvements in soil quality in a long period of time. So to start with, are these farmers that you interview educated on soil quality and how you measure soil quality? Could be a complex measure. And second, are there differences across the regions? Like, as you said, there were X number of villages that you interviewed. Are there differences in their landscape that could make some farmers more eager to understand the soil quality aspect because they have been more exposed to changes in soil quality?
So the landscape is fairly flat throughout the country. There are some mountainous regions, but not in this area. And these areas were chosen just simply low, medium, and high rainfall relative to other parts of the country. In general, there are very low levels of education among these farmers. And when we went into the other experiment in Malawi and in this one, we were assuming that farmers did not have a great deal of agronomic knowledge about the fertility of their soil. But we were surprised that they clearly did. They understood that they are farming on degraded soil, that they're farming on marginal soil, and that investments in things like legume intercropping and so forth can be valuable in terms of bringing nutrients and nitrogen into the soil. So yeah, they're very knowledgeable about soil maybe from a non-scientific perspective, but they understood what actions they do that harm soil quality and what actions they can do to improve it.
So you interviewed 10 men and 10 women per village. Were you able to get equal numbers? And what is the percentage of women that do agriculture? Generally.
Generally 100%. I think our sample had slightly more women, perhaps because of availability. Some men will get wage-paying jobs off farm and are not at the household, when we were visiting. But I think we had roughly 52%, 52% women. But almost all women farm. They may farm different crops. Men more commonly will farm cash crops. Women are farming food crops, but men and women actively engage in farming.
So would women be more likely to be farming soil?
Yes. Yes.
To add to Dr. Velandia's question, so I know this is a hypothetical experiment. So when you have these choices of levels of different attributes, I was just thinking is it possible that high soil improvement and high forest biomass can be independent, or there are some economic or biological differences that doesn't allow two things to come together?
It's a good question, and it's one reason why this method is often criticized. Where's my? So in something like soil improvement being low and high, and it being low or high relative to whatever you think is low or high, or yield being relative to whatever your yield was in the previous year. Those kinds of variables make this kind of experiment very hypothetical. And so we should take caution not in looking at something like this, ability to reuse seeds, as being the price of 33 CFI for that attribute. What is more relevant is to compare the relative value of something like that attribute to the other ones. And we see that, say, the ability to reuse seeds is 6 times more valuable, 5 times more valuable than plant duration as an attribute. So the appeal of the results is really in their relative value, not their absolute value.
Yeah, when I look at the estimates for Perennial sorghum, it seems like soil improvement and biomass for it both have good coefficient, right? So it is all of the farmers say we want both of them high, right? But we are not sure if breeders or agronomists can produce that kind of sorghum for climate adaptation.
No, absolutely. Well, and certainly, a rational farmer is going to say, well, I want the scenario that has low seed requirements, low labor, high biomass for forage, high soil improvement, high sorghum yield. So you want all the good things, but we force the experiment the experiment forces you to confront trade-offs. You don't always get the good things. And so there are going to be times when yield is low and soil improvement is high, and you have to ask yourself, do I want that? Or you could flip it and say, what happens when yield is low, but we end up with lower soil quality? So it's the trade-offs that really is the valuable aspect of this kind of approach.
So what are the seed markets like? Easy to buy seed for these farmers?
Well, as you saw from the average distance to a market is around 20 kilometers. So traveling to a market to purchase seeds can be an obstacle for some farmers. But seed availability is generally high.
In the appropriate size packages that we've seen in other places where seeds are there, but farmers you can only buy in bulk well beyond what they need.
Yeah, sometimes that is a problem if they can't afford the packaging that they come in. And yeah, it certainly varies across the country. And sorghum, because it is not promoted as much as rice and millet, may be less available in some places. So again, plays to the kind of hypothetical nature of the experiment.
And is that availability of the traditional varieties of sorghum or hybrid or both?
Hybrid, because the traditional variety farmers would have saved seeds from last year, replant them, it's again sorting out the ones that were most desirable, replant those again. So most farmers, practice that kind of sorghum cultivation and may not be buying seeds every year. And as we see, there's a strong preference against the inability to buy seeds.
I have another question thinking ahead. Like, so when you lay out your objectives, you were talking about that the motivation behind this project has to do with food security, right? But then there are other crops that are more popular, like rice and milk. Have you contemplated, or is there money available to look at food preferences and diet? Because I've seen a lot of those kinds of projects in other developing countries where they disregard the diet of the consumers. So they provide a crop, but it has nothing to do with their food preferences. And so it's not really addressing the problem. So is there already literature or information that talks about their diet and how likely they are to increase their consumption of sorghum if you're going to provide this as a viable alternative for them?
It's a great question. There is literature that suggests that there's growing interest in sorghum because of some of its characteristics. Rice is widely promoted and people consume it, but it is not resilient to climate change. And part of the appeal of sorghum is that it is hardy to warming temperatures, soil salinity, and drought. So in that sense, this is a classic kind of expert-led project. The Gates Foundation came to us and said, would you explore the potential for perennial grains? And we knew people at ICRSAT that were breeding perennial sorghum, so that's why we chose sorghum. But this is the Gates Foundation saying, here's an idea. Perennial grains, they save labor. They're good for long-term ecosystem services in soil. But no, we did not start by asking, wait, do you like sorghum to begin with?
Because it could be that there is another alternative that is more in line with their culture and their preferences that has also those production benefits that you are looking for in terms of resilience to climate change.
You're exactly right, and I think one of the challenges here is how to balance the reality of cultural preferences with the reality of climate change. We can think about here in the United States how much corn and soybean is grown, and we know how nutrient intensive those crops are. We know that cultivation of those crops contributes to a lot of environmental challenges, but still there's a preference. There's a reason why we grow them. Maize is a staple crop in many countries in sub-Saharan Africa, and is probably the least, the crop that's the poorest suited for resistance to climate change. So yes, in a place like Malawi in southern Africa, most farmers will grow maize, even though it's a very challenging environment. It was an introduced crop from centuries ago, and now it is the most preferred, even though it's not resilient to climate change. Weaning farmers off of maize, I think, is going to be a very big challenge. It's going to be very difficult to grow it in the future.
I think that's a very interesting study. Obviously, discrete choice modeling is very popular in a lot of fields. So I just get a one point want to make clear. Would you mind go back to the attributes and the levels, please?
Sure.
I think you might have pointed out. So just for many of the, not many, some of the attribute, for example, the plant duration, when you mean early, medium, or late. Oh, this one has definition, but when you go the next slide. Yes, when you what do you mean by low and high? There were no quantitative value assigned to each of those attributes. So it's pretty much like a conceptual idea. The farmer has to figure out in their mind what's the meaning.
That's a very useful observation. The reason for this is that hybrid sorghum actually exists.
Okay.
So it is people are breeding hybrid sorghum now, selling that seed that cannot be reused, and farmers are growing it. So we know something about early duration sorghum because it has been field tested, and the shortest duration you can get is just under 4 months. Some of the traditional varieties go up to more than 6 months for time in the field. So this is a crop where we actually know something about it. As I mentioned before, Icrasat is breeding through crop trials perennial sorghum, but it is only a demonstration crop at this point being studied. So farmers are not growing it. We could have had some estimates of those from what Icrasat is doing in the lab, but farmers wouldn't be familiar with this kind of crop. So we decided to describe it in qualitative terms and then let them come to their own conclusions about what low or high is. I mean, to Margarita's question before, for soil improvement, I'm not sure that we would have an indicator that would be easily understandable or easily measurable if we said, nitrogen content of your soil is X, Y, and Z. So low and high seem to be more appropriate for this more hypothetical crop. The other crop we know more about.
Gotcha. This could be very difficult for you to make the product. So
Yes. Again, it's one of the appeals of this kind of method is to study a hypothetical market, but because of the hypothetical nature, you sometimes have to use qualitative measures.
Any other questions? Not, please go ahead.